Good day, everybody. I'm Nizar here. So we're with Team 8, Group 8. So we've been given a sample of about 200 for tablets, and I've been asked to summarize it for my group. Now we've been given 3 different sectors. So we're dealing with weight, tensile strength, with relative density, as you can see in my screen here. So starting off with weight, I've divided into 8 parts, and with intervals of 10 between each other. And then I've taken the value frequency and put it into the count, which is the next column. So based on it, you can see that the values between 340 to 350 has the highest frequency, 51, and the lowest would be shared with values greater than 380. So no tablets. Basically, the number of tablets above 380 milligrams is just 2 of them. It's kind of rare. So the next table, we have tensile strength. So we divide it into 0.1. We've divided the levels by 0.1. And as you can see straight from it, the highest frequency being the row label 7 and the lowest being shared at the extreme ends. Now this will be better visualized in the graphs. We'll go on later, but right now we're just going through the tabular form. So the final table we have is relative density. This is a more lengthy table where we have intervals of 1. And the count, as you can see, is being shared the highest between 86 to 87 and the lowest again at the extreme ends. Now this will be better visualized when we get to the graphs. So next up we have the numerical form. Of course, this has been derived from the tabular form, and we've put in X standard deviations, variance, mode. And so for the different classes of weight, relative density, and tensile strength, so based on it, you could see the X values for X. For weight is 350, for relative density is 88, and for tensile strength is 7.112. And the standard deviation, not very big, 14.67. For relative density, even smaller, 1.9. But given that the relative density's values were very packed to begin with, it's not surprising seeing such a small standard deviation. And our tensile strength is even smaller. Now we have the variance, and then we have the mode. The mode, of course, we've already explained it before, but the shift morning and evening is the highest occurring across the 200 samples, so it's the highest over here. Now the second table, pretty much the same as the first table, except it has a row. It has a row of morning, evening, and night, so it's basically shift based. This gives us a different perspective of the same data. Now finally, we have graphical form, which is the best top eye view of the whole data. As you can see easily from weight, you can find out that the highest, based on the histograms that we see before us, for weight it's very packed between 340 to 350, and the extreme ends are the lowest in frequency. As well as relative density, it shares the same pattern where the ends are extremely low while the middle is higher. Just an uneven change here between 86 to 87. And tensile strength, however, does not share the same patterns as weight and relative density. It has a more uneven distribution for its strength, but this is understandable because it has a very small standard deviation, a very small amount of variance. So small changes make very big deflections. So it's pretty interesting summarizing the data, and that would be all from me. Thank you very much.
So for this second equation, we can see we must find the weight distribution for this equation. So as you can see, I have made the table between the range and the frequency. And the question have given the number of mean and standard deviation, which is mean is 350 and standard deviation is 14. In this question, we must do the hypothesis, which is H0 is number of weight that is distribution that follows the number of distribution, and H1 is number of weight that does not follow the normal of distribution. In this question, the number of EI is equal to NP, which is N is number of sample and P is number of probability. For the table of purple, as you can see, I found the lower boundary and upper boundary. This boundary is to find the number of probability. The Z1 and Z2 have been defined by using the formula of X minus mean over standard deviation. The number of probability have been found based on the number of Z. We find the number of probability based on the table of A4.
So based on the green table, the EI, as my friend said, we obtain by multiplying the number of sample and probability. So as you can see, the first class of EI is 0.42, which is lower than the number of class, which is 9. So we must add up until the first 3 class to get more than 9. So the first class of OI and EI is added to get the new value of class. So this green table is the new value of, which is the, so this is the new table we obtain after the EI is added until higher than 9, which is there are 6 class. So we compute with a chi-square test with this formula, and the total we get is 5.73513488. So after that, we get the critical value is 11.0705, and we use the significance value of 5%, which is alpha, which is 0.05. So since the critical value we obtain is smaller than the critical value, we accept the value of H. So there is no significance difference between the tablet weights. The number of weight follow the normal distribution.
Sample it is come from. This is our hypothesis statement. As H0, U1 equal to U2 equal to U3 until you get in this hypothesis statement, we state that there is no significant difference exists between tablet weight from the different shift. However, in hypothesis statement 1, we assume that there is significant difference exists between tablet weight from the different shift. This is our test statistic. Firstly, we have summary. The second one we have ANOVA. For the summary, we using the Microsoft Excel to sum up the different shift in morning, evening, and night with sum, which is the total, the average, and then the variance. For ANOVA, this where for the hypothesis relationship, for the hypothesis anything about hypothesis is the p-value of the calculated in the statistics. We get that the p-value is 0.484166, which is less than the alpha value, which is the p-value 0.05. And then based on the output above, based on this output, the p-value equal to 0.484166, and we choose the significant value level is 0.05. And then we notice that the p-value is less than the significant level, which is 0.05. Therefore, we accept H1 statement and concluded that there is significant difference exists between tablet and grade in the different shape. With that, I rest the case. Thank you.
Hello and good day. My name is Nashiveta Shani Swaini. I will proceed to the last question, which is part D for this assignment. The question for part D is what the prediction of the tensor string for such tablets, and comment on the validity of the model that you have used to carry out this prediction. If you can see, the model is used to predict a dependent variable from any value in the independent variables using the regression analysis model. There is a relationship between one or more response variables and one or more predictor variables. The response variables are also called dependent variable, which is a tensor string. Then the predictor variable are called independent variable, which are relative density. 95% confidence in the linear relationship between the tensor string of the pill and the relative density is valid. The equation to describe this relationship is y equal to mx plus c, where y is a tensor string of pill, m is a gradient of the line, x is a relative density of the pill, and c is intercepts. As we know, by using the SL, we will obtain the regression analysis in this table, which is for intercept and relative density, we can get the value from coefficients. Based on the linear equation at the top, we will get the linear regression equation is obtained as y equal to 0.0x0895x plus 0.018275, which is it from the graph. If you can see this is a chart comparison, and show that the orange point is described for predicted tensor string, while the blue point is for tensor string. And the line of orange here show the linear line in the chart. The fact that the tensor string should be 0 when relative density is 0, and the value of intercept should be at 0. Okay. From the linear regression equation, which is y equal to 0.80895x plus 0.018275, we can get the predicted tensor string at 98%, 74.3%, and 80.1%. As we can see that at 68%, the tensor string is 5.519Y35 MPa, and for 74.3%, the tensile string is 6.028775 MPa, and 80.1, the tensile string is 6.497965 MPa. So there is a summary output of regression statistic where it shows the value for multiply R squared, adjust R squared, then the error and observation. So multiply R is 0.838285. So look at this table. We can see that the multiply R we know as a value coefficient. So that means that multiply R is same as a value of correlation coefficient. So in the conclusion, by using the test result of the tensor string from the relative density, we can use the linear regression model with up to 95% confidence level. So that's all for me. Thank you.